What is the potential difference VA minus VB between the points A and B in the given figure? We are asked to find the potential difference VA minus VB across the given circuit. We are given a current I is equal to 2 amps and resistor 1 has 2 ohms resistance, resistor 2 has 1 ohm resistance and a battery of 3 volts. The current I is equal to 2A is flowing through each resistor in the circuit. The potential difference across a resistor R is given by Ohm's law, which is nothing but V is equal to IR. Let us calculate the voltage drops across 2 ohm resistor. Applying Ohm's law, we get V is equal to IR. I is nothing but 2 amps and R is nothing but 2 ohms, which is equal to 4 volts. The potential difference across a 3 volt battery is 3 volts itself, and the potential difference across 1 ohm resistor is given by again Ohm's law, which is V is equal to IR. I is nothing but 2 amps and R is nothing but 1 ohm, which is nothing but 2 volts. Let us now apply Kirchhoff voltage law, which states that the sum of potential differences around a closed loop is 0, and it can be written as VA minus 4 plus 3 plus 2 is equal to VB. On simplifying, we get VA addition of all this is nothing but 9 is equal to VB, or this is equivalent to VA minus VB is equal to 9 volts. So the potential difference VA minus VB is plus 9 volts. Answer is option B.